What do you think about the alternate theories? Do you think there's anything interesting in those?
Many of those theories are espoused by passionate people. They have fans. People love them, but they don't do what science needs to do, which is make predictions. Now, loop quantum gravity is a little different. That one is better developed. And that one is not a theory of everything. So we should make that clear. Loop quantum gravity is not a theory of everything. It is simply a theory of quantum gravity, period. It does not aspire to include all of the known forces. It simply tries to take gravity, which is currently intrinsically, it treats space as smooth and continuous. For those of your viewers who are mathematically inclined, in Einstein's theory of general relativity, gravity is infinitely divisible. There is no smallest bit. And so essentially the laws of calculus apply.
Mm-hmm.
However, it is possible that at a small enough scale, space is no longer divisible in the same way that you can, take a cup of water out of a swimming pool and then a quarter a cup and so forth. But eventually, once you've taken out a single molecule of water, you can no longer take out a smaller thing. So loop quantum gravity attempts to quantize gravity. So that's what it does. And so this is unlike string theory, which attempts to bring gravity in with the other forces. And in fact, the one reason why string theory became so interesting to the theoretical community is string theory was not being developed as a theory of everything. It was being developed as a theory of the strong force. And it was in competition with QCD, which is the currently accepted theory of the strong force. And it turned out the two groups, the string theory groups and the QCD groups, competed for a while, and string theory basically failed the race, and people paid attention to quantum chromodynamics, QCD. But then somebody noticed in string theory that one of the things it predicted was a zero mass spin 2 particle. And you can prove that any zero mass spin 2 particle is the graviton. And so if you see a theory that has a zero mass spin 2 particle, you now have a candidate for dragging gravity in. And then, oh my gosh, people got terribly excited because now this theory, which was working in the direction of the other quantum forces, brought in gravity, and now it was a candidate theory for everything. But that's not what loop quantum gravity is. Loop quantum gravity is simply trying to understand the nature of space itself, which is already a fantastic thing. And I talk to Rovelli every so often. I write about his theory, and I point out some of the issues with the theory, but I'm usually about 2 months behind as he and his colleagues are developing and so forth. Because one of the things is originally loop quantum gravity predicted that the speed of light would not be universal. The speed of light would depend on the frequency of the light. So high frequency would travel at one speed and low frequency would travel at a different speed. And it had to do with the wavelength of light basically interacting with the structure of space, And so that was an issue with loop quantum gravity. And so if you look at gamma ray bursters, which are super explosions of astronomical events that are a billion light years away or more, and they spit out light in all wavelengths. And if that loop quantum gravity prediction were correct, when you saw one of these gamma ray bursters, you would see the wavelength of one light appearing on Earth at a different time than another wavelength because of the different speeds. And that wasn't the case. They appear at the same time. And so I went on to say, well, this pretty much killed loop quantum gravity, only to get a prickly note from Mr. or Dr. Rovelli saying, we've disproved that. We've changed the theory. That's no longer true. And now that prediction, that old prediction of loop quantum gravity is no longer valid. And so that observation of the uniformity of the speed of light no longer kills the new loop quantum gravity. It would have killed the old one, but it didn't kill the new one.
By the way, that example of different speeds of light based on wavelength, that's a beautiful thing that a theory, that's a testable thing.
It is.
right? So like those kinds of things, and if it in fact did explain a phenomenon of that sort, that's a good sign for the theory, right?
Hmm.
If it correctly predicted.
There was another brilliant observation recently. Love it. The observation of gravity waves.
Mm-hmm.
And it was from two neutron stars orbiting and coalescing. And so they made gravitational waves, fantastic. But they also, because they were not black holes, they were neutron stars, they hit and it exploded, gave off a tremendous bright flash of light. And so astronomers saw the flash.
Mm-hmm.
Gravitational wave astronomers saw the ripples of space-time. It was 140 million light years away, which means light would have traveled 140 million years to get here. And the two incidents, light and gravity, both arrived within 1.7 seconds of one another. And that tells you that gravity travels at the speed of light. That was a brilliant, fantastic measurement. Now, we thought gravity traveled at the speed of light, but now we have a measurement, we proved it, and damn it, I am impressed.
Our universe is so fascinating.